The section is called Fundamental Theorem of Calculus, and this is in Chapter 5 when we address this. So I'm going to address 3 examples of this because we keep on approaching to these kind of problems when we do our AP practice problems. So when you have an example 1, and we have a derivative of the integration of cosine t dt with the limits of x squared and 1, what we're actually going to do is we're going to take the derivative of this integration. Now when you take a derivative of an integration, it's going to cancel out to the original equation, which then is that cosine t. So cosine t doesn't change right here. But what gets a little tricky is the limits right here. So when you take the derivative of this integration, you're also going to take the derivative of the limits as well. So it's almost like this right here is the derivative part that you need to include as well. So which is like the chain part of it, okay? So let's go ahead and try this. So if I take the derivative of this right here, the integration, what happens is the integration cancels out, and when the integration cancels out, then also this dt part of it cancels out. So then you're just left with this cosine t. And then I have is my limits from 1 to x squared. Now when I actually do the substitution part of it, I'm going to have is cosine, and then I'm going to substitute in x squared, so x squared, and then times, we have as the derivative of x squared because we took the derivative of also this part and this part right here. So it's just not just the integration. It cancels out the integration, that's true, but then you'll also have to think about it is that you have to take the derivative of the limits as well. So when I take the derivative of the limits, which is the x squared, derivative of x squared becomes 2x right here. Then it's still minus, and then I do the same thing on the next part. So it's cosine, and then I have 1. Derivative of 1 is 0 right there. Okay, so obviously this cancels out to 0 because anything times 0 is 0. So then you're just left with is, I'm going to put the 2x in the front here, and then cosine x squared, and that's my final answer right there. Okay, let's try another example. Now this example right here is similar to what we just had in example 1. The only part is, the tricky part is I always have to have the variable on the top and the numerator on the, or the number on the bottom part of it if we're given something like this, okay? If there are 2 variables, it's kind of like one of the rules, the fundamental calculus rule, that if you had to have a negative number or a smaller number on the bottom, and then you have to switch it up. So in that same sense, I have to switch this one up right here. Okay, so then I'm going to go ahead and switch it up. So I have is d over dx, and if I switch my limits, right, I have 5 and x right here. It's the same rule as the limits when we have a small number and also the big number. If it switches, we have to have a negative on the outside right here. Okay, so then from there I have is still 3t and then sine t dt. Okay, so I just rewrote it. The only thing different is switching of the limits right there. All right, so now let's go ahead and take the derivative. So if when I take the derivative of this integration, it's the same rule. The integration and the dt cancels out right there. It's kind of like the period right there, so we cancel this out. But we also have to take the derivative of the limits right there, okay? And I have to include this negative right here, so I'm going to go ahead and include that negative. So this right here will cancel out, the dt, the derivative of the integration will cancel out right there. So and then I have is 3t sine t with the limits of x and 5 right here. Okay, so now the substitution part of it. So it's negative 3, and then I have is x right here, because wherever there's a t, right, from here and here, we're going to substitute in the limits right there. So I have is 3x, and then I have a sine x, right, times the derivative of x. So derivative of x is 1, so that's not affecting us right there. So that's this part right here, minus, and I should probably put a bracket because I still have that negative on the outside. So then in parentheses, and I have is 3 times 5, and then we have is sine 5, right? And then times the derivative of 5, which is 0. So you can see already, it's always, anything that has a number, it's always going to cancel out to 0 right there. So if you want to take a shortcut on the multiple choice part of the test, you may not have to include the numbers, but with variables, it makes a difference right there. Okay? So now to simplify this, so this goes out to 0 again. And then right here, I'm just left with then is negative 3x and then sine x. You don't necessarily have to include that 1 right there because 1 times anything is itself. Okay, now let's go the other direction. So we've had a couple practice problems where it's the other direction, which now is the integration, and we have it as a derivative in the inside. So when you have a derivative, when you take a derivative of something, and when you take the integration of that derivative, it goes back to its normal self. So what happens is now, in this case, the integration and the derivative part right here cancels out. So you just have is the original equation, that f of x equation right there. So I have is then f of x right there. And my limits are from 3 to x right there. Now this right here, this is not affected in this case. It's the opposite from examples 1 and 2. In examples 1 and 2, we took the derivative on the outside, so the limits, you also have to take the derivative. It's like the chain part of it. Whereas this one right here, I'm actually taking the integration of the derivative, right? So then this right here is not affected. So we just substitute in, then I have is f of x minus f of 3 right there. And there's nothing else I can do with that one, so we're just going to keep that as your final answer right there. All right, so hopefully that clarifies the definition. So again, if you take the derivative on the outside of the integration, you have to just then basically cancel out the integration, right, and the dt as well. And don't forget is to take the derivative of the limits, just like a chain part of it. But if you have is the integration and then derivative in the inside, it cancels, the integration cancels out the derivative, and the limits right there is not affected. So you just substitute in the limits, and then you're done with the problem right there. Okay? All right, go ahead now and practice these problems.